Okay, it's 9:40, so let's get started. So, big day, right? Oh yeah. If you haven't seen homework 3 is actually out. The first part's due not this Sunday, but the following one after that, and then part 2 is due later. And that has to do with CFL scholars. So, any questions before we start? Yeah.
Why is it a weekday?
What's that?
Why is it a weekday? Just as a
It's the 11th? Is the first part? Oh, sorry. But why is it a big day? Can anyone tell me? It's our today. So, any other questions before we start? Okay. So, what was the main thing we talked about last week? Oh yeah, that Chomsky Normal Form. So, Chomsky Normal Form for CNF. So, what is this? What is it talking about?
It's the transformation of a context-free grammar.
Oh, okay, so something to do with context-free grammars, but what about CFGs are we going to do? And what does this actually restrict on the grammar?
Rules.
Yeah, the types of rules that we can have. So a CFG and CNF only has rules of the form. And then, so what does CNF tell us that we need to have as the types of rules? Well, I always will have a variable on the left-hand side. That's never going to be untrue. But what can I have on the right side?
Where the start variable.
Okay, so I can go to 2 terminals. So, two variables, because I need to get to other variables, because if I don't allow that, then I can't generate anything interesting. So where B and C are not start variable, and we'll see why that's important in a second, but what else should I be allowed to do?
single terminal?
Go to a single terminal, right? Because if I don't allow that, then we're toast already. But what am I forgetting?
Empty string.
Empty string, right. So what thing can generate the empty string?
Start.
Only the start variable, whatever I call it to be. Okay, well, why don't I just allow you to go to 2 variables and ignore the fact that I can only have the start variable go to epsilon? Why can't I just allow you to have these 2 and I don't have that condition?
You got unit rules.
What's that?
You got unit rules.
No, I said that you can have either 2 variables or a single terminal, but I should allow you to have any variable go to epsilon, and and B or C could be the start variable. Why do I restrict it this way? It's actually a very good reason. Because if I allow you to have these be the start variable, and anything generate epsilon, then I may have multiple ways of getting the empty string. And so the whole reason for this is, if I restrict it so that these 2 are not the start variable, then that means that the things of these 2 variables must generate something of the final string that I want. It can't be the case that these generate epsilon because this is the only way to do it. So it's progressing toward a string that I want to. Okay, so that's actually one of the main reasons. But why do we even care about CNF? What's an advantage of having things in CNF? There are actually several.
Binary parse trees.
Oh yeah, binary parse trees, yeah. So it makes the, so the parse trees look easier. What's another advantage? What was Sorry?
Simplification?
Yeah, I have simpler rules, but do you know of any other one? So this one's kind of obscure, but you can actually see it. How many of you have heard of first and follow sets? So it's things that you can generate if you look ahead, essentially. And if you have things in CNF, it's much easier to compute the first and follow sets. So, but what did we actually show? Can any grammar be converted into CNF? Yeah, we showed that any CFG following a set of rules can be converted into an equivalent grammar in CNF. So what were the steps that we came up with? Right, since I don't want the start variable on the right-hand side, then I better have a grammar that has the same language that doesn't have the start variable on the right-hand side. So, I'll leave this vague and then we'll talk about it in a second. So make sure start variable not on right-hand side. Okay? What did we do after that? Right, so what we wanted was, we wanted only the start variable to make epsilon. And if another variable makes epsilon, like A in this case, then we don't want that to happen. So I'm gonna leave this in quotes because it's not literally just eliminate these things, but you get the idea. So eliminate, in a sense, epsilon rules. Although the word that should be here is really simulate, because what we're going to do is we're going to simulate as if we took that rule with other rules. Okay? So that's the idea. What did we do after that? Remove these unit rules, right? Because I need to have exactly two variables, and so it can either be the case that it's a single variable or two or three or more. And so we're going to do this in stages. We're going to remove the ones that have exactly one first, then we'll ensure that it's only variables on the right-hand side or a single terminal, then we'll break up the long sides. So, like in this case, S goes to B, I don't want that to happen. So, again, eliminate quotes, but it's really simulate unit rules. And remember, unit rules are rules that have just a single variable on the right-hand side. What was the next step we did?
Break up long right-hand side.
Before we get to there.
Make sure variables only shoot one terminal or two or more variables.
Right, so I can't have the case that I have a single variable after step 3 because I just got rid of them. So in step 4, I may have rules that look like this that are a mixture of variables and terminals. And according to the definition of CNF, I don't want that. So what we could do to get down to two variables is whenever we have a long right-hand side that's a mix, then what we do is convert the terminals into variables and then afterward break them up. So ensure right-hand side is either single terminal, at least two variables because I can't have one, or S goes to epsilon. Because I need to have that. I need to be able to have that. All right, but then what do we do at the very last step? Yeah, then break up the long right-hand sides. So break up long right-hand sides. Okay. So any questions on how this algorithm goes? So why do we do it in this way? Why don't I say eliminate epsilon rules first, and then do unit rules, then do this step, then do 5, and then do 4? Why do I do it in this way?
other rules don't like nullify themselves?
Right. If I do these in a different order, then I have the risk of reintroducing rules of the form that I don't want from previous steps. So if I do, you can actually prove, but if I do it in this way, then once I do step one, I'll never introduce a rule that has the start variable on the right-hand side. Whereas if I started with some other one, I might. If I do one, then two, then when I get to step three, there's no way I'll have epsilon on the right-hand side unless it's the start variable. I'll never reintroduce things that I don't want from previous steps. Okay, so that's why we do it in this order. But any other questions? Okay, so I have a kind of complicated grammar. Let's convert it to CNF. So I'm just letting you know right now it gets kind of big, so just leave a little bit of room. Okay, so I have three variables, S, A, B. S is the start variable, and A, B are the other ones. And little a, little b, little c are the terminals. So what's the first step to convert this to CNF? The start variable can't be on the right-hand side of any rule. Is it in this grammar? Yeah, I see it here and here, so we better fix it. So what is an easy way to fix it? Yeah, so the basic idea is let's just make a new start variable that goes to the old start variable, and that'd be the only rule for that, and then keep the original rules. So I'm going to make a new variable called S0, which is my new start variable, which goes to S, and then I'm going to keep the grammar exactly the same as I had it before. You don't have to write the original rules, I'm just doing it for completeness. And something really important to know. Since any grammar can be converted into CNF, what do we want of the resulting grammar compared to the original one? What do we want to be the same between them? Yeah, the language. We don't want to change the language, because if we do, then we may have some context-free languages or context-free grammars that can't be converted into CNF. And so so I need to ensure at every single one of these steps, I never change the language. So do I change the language when I do this step? No, well, let's see. Well, suppose that we had a derivation in this grammar. Can I make one here? Well, yeah, whatever derivation I did up there, just add on at the beginning, S0 goes to S. So that's not a problem. What about a derivation in this grammar? Can I get one in the original grammar? Well, I think so, because the only thing that S0 what rule it is involved with is S0 goes to S. So any derivation in this grammar must start with that. So delete that part, and then that's a derivation in the original grammar. So we really don't change the language by doing this. But any questions about this? It's a pretty easy step. So I'm going to leave a little bit more room for the next. So what's the second step? Eliminate, quote unquote, the epsilon rules. So do we have any epsilon rules in this grammar that we don't want? Yeah, we have a non-start variable go to epsilon. Okay? So I need to simulate as if I took A goes to epsilon with adding more rules. Okay? Well, how did we do that? What was the process we did for doing that? Starts with an N. What kind of variables do I want to find? Nullable variable. Oh, what's a nullable variable? Yeah, so we want to find nullable variables. And so And those are of the form, some variable can, at least one rule, generate the empty string somehow. Well, clearly A is a nullable variable, so I should write that down. So A is definitely one, but are there any other ones? Yeah, it looks like this rule S goes to A. I think that will make S nullable because there is a way for A to make epsilon. This A makes epsilon, this A also makes epsilon. So I should make S nullable. Any other ones? Ooh, are you sure? Well, I just determined S is nullable. Oh, I think that means S0 is also nullable. Okay, so S0 is nullable. Any others? Well, let's see. The only other one could possibly be nullable is B. Well, we determined that A and S are both nullable. So can this rule right here, ASA, could that say that B is nullable? No, because even if A and S dropped out, then I would still have to generate a terminal here. What about this one? No, for the same reason. We actually don't know if B is nullable yet. And even if we did, then this rule goes to B wouldn't help me here. So I think the only three variables that are nullable are A, S, and S0. Okay? So once I have this list, what do I do? Well, I kind of hinted at it. We are going to simulate as if those variables dropped out. Well, they may still make something that's not empty, so I need to keep all of the existing rules here, except A goes to epsilon, obviously. But all the other rules I'm going to keep there, but add other ones, as if I'm going to go make those variables go to empty. Okay, well, let's see. So S0, better make S, because I'm going to keep all of the existing rules that don't explicitly make epsilon here. But what should I add to this? Epsilon, right? Because I determined S0 is nullable. Okay, so that's good. Let's go to S. Well, as I said, we're going to keep all of the existing rules. So every non-epsilon rule is going to stay there. So now here, I got to simulate as if, since B is not nullable, A is nullable, I need to simulate as if A dropped out. Well, how many possibilities are for A dropping out here? Well, this one could independently stay there or drop out, independently stay there or drop out, independently stay there or drop out. How many ways is that? I think 8, right? I have 2 choices for each of the 3 positions. Well, the good thing is they're all the same variable, so I won't have to add 7 more rules. So if one of these A's drop out, I think I have 2 A's now. So A. If 2 of them dropped out, I would have a single A. And I could, well, actually I should. So if all 3 of them dropped out, then I need to add epsilon. Don't worry, I'm going to get rid of it. But I'm just simulating all the ways that they could drop out. Okay? So I handled this rule. What about this one? Just a single character A, right? Because either this A stays or drops out. If it drops out, then I only have a single terminal A, and terminals don't drop out. So I would have a single A here. What about S goes to B? Should I worry about that one? No, but because B is not nullable. And even if it were, then I already had S to epsilon, which I will get rid of, but I've already handled that. So we're done with S's rules, so that's good. Okay, so let's do A's rules. So I'm going to keep exactly the same rules as I had before. No changes. But let's see. We have these 2 variables, and both of them are nullable. So I need to handle the case that both are present, which I do here. I need to handle the case that exactly one of them drops out, which will add 2 rules. And I need to simulate the case where both of them drop out. So it could be the case that this A drops out and this S stays. So I should have B, C, S. It could be the case that this A stays and this S drops out. So I should have B, A, C. Or it could be the case that both of them drop out, which means I would have just B, C. Okay, it's just all it is simulation. Okay? And so that role's done, and A to epsilon, which I will get rid of, is also done. So that's good. Let's do B's rules. So again, I have nothing changed. Okay. Again, I need to have all 4 possibilities for these 2 variables to drop out. So both of them are present here, so I got that case. This A could drop out, and this A could stay, and this S could drop out. So I need to handle that case. AA. It could be the case that this A drops out and S stays, so I need to have SA. And I need the case where both of them drop out, which is just A. Do I need to worry about the BB rule? No, because B is not nullable. So I think we're done with B's rules, and now we've simulated everything. So now, all I need to do is remove all of the epsilon rules that I don't want. Well, I better have this one, because there was a way to make the empty string, so I better keep this. But I want all the other ones to go away. So I'm going to eliminate this one, so we'll have an A there. This one will go away. So I can't switch them over, but you get the idea. And B didn't have one, so yeah.
Why didn't S0 go to all the ones that
I'm just eliminating the epsilon rules. I haven't handled unit rules yet. But I'm just doing epsilon rules. Any other questions about this? Okay. So what's the next step? Unit rules. So I guess I can do it over here. So step 3. So hopefully I won't run out of room. So what's the unit rule again?
One variable, one variable.
Yeah, it produces exactly one variable. Do we have that case here? Yeah, we have 2 of them, I think. S0 goes to S. Oh, 3, sorry. S goes to B, and S goes to A, so we better fix this. So how am I going to fix this? How did we do it in class?
Replaced all of what S has.
Well, I could do that, but I also have the case where S could go down to B or A. So I may have like a chain of these things that go down. So what is an easy way of doing this? Do it, yeah, make a directed graph. So make a directed graph. And so what are the vertices of this graph? Well, I think the variables of the grammar. So I'm going to have 4. It's going to be a very boring graph, I'll tell you that. But it's going to have 4 vertices. And then how do I make directed edges? Yeah, for the unit rule. So I see S0 goes to S. So that should be a directed edge or an arc. S goes to B, so I should have a directed edge there. S goes to single A, so I should have a one there. A doesn't have one, and B doesn't have one. So a boring graph, but pretty simple though. So how am I going to use this graph to benefit me?
The leaves.
Yeah, so just look at the leaves. So I have two leaves here, A and B. Well, leaves in a sense. So what am I going to do with that information? Well, A doesn't have any unit rules. So whenever I see just a single A on the right-hand side, what can I do? I can just copy the rules up to where that A occurred. I think I can do the same thing for B. Okay, so we're gonna build this bottom up. So B's rules and A's rules are obviously gonna be untouched. For B, or A, or SA, or A. BACS, or BCS, or BAC, or BC. So for S's rules, other than B and A here, everything else is still going to be there. So nothing's going to change about those. So S is still going to go to A, or AA, or double A, or single terminal A. But, so now let's simulate S goes to B. Well, that means I should be able to just copy the rules in that B is on the left-hand side up to where that is, because B doesn't have any rules. So let's add those rules up to here. So I would have ASA, or I told you the grand rules are big. BB, or AA, or SA, and the good thing is B produces a single A, and I already have that, so I don't need to have it. Okay, so now what do you think I'm going to do next? Add A's rules up. So that's for BACS, or BCS, or BAC, or BC. And I don't think I duplicated one. So, what do you think I'm going to do about, so we handled these edges right here. So do I have an edge left over? Yeah, I have S0 goes to S, so I need to handle that one. So how am I going to handle that? Well, I think since now S doesn't have a unit rule, I can just copy everything up. And instead of literally writing everything down, I'm just going to do this. But did I change anything? If I just did that? Yeah, what have I forgotten? Yeah, epsilon, yeah. So the danger of doing it this way, I recommend doing copies, but the danger is leaving out rules that you already had. So just watch out for that. But any questions on how we were able to do that? What's the next step? Yeah. So do we have an instance of a mix of terminals and variables on the right-hand side? Yeah, I think we do. We have this one, actually quite a few. So we better fix that. So I don't want to erase this. I don't want to erase this, but I guess I have to. Step 4. So what we want is either a single terminal or 2 or more variables, or the start variable goes to epsilon, which we already have. So how am I going to do that? Oh, okay. Maybe for the right-hand sides that have more, that do have a length at least 2 and have a terminal in them, just convert the terminal into a brand new variable that didn't exist before. Should I do that for this one? No, why did not? It would add a unit rule. So I should only do this when the right-hand side has length at least 2, right? Because if it has 1, it can't be a variable because I just eliminated unit rules. So the only thing that has length exactly 1 is a terminal, and I better not replace those because it's already a rule that I want. So what we could do is, let's convert each of these terminals into a variable. So I'm going to add variables. Well, what are the terminals in this grammar? Lowercase a, b, and c, right? So I'm going to add 3 variables: use of a, use of b, use of c, and rules. Use of a produces a, use of b produces b, use of c produces c. I always made a joke in my recitations in the previous semesters that U of A is so incompetent they can only produce 1 character. But now, what do we got to do with these variables? I went all the expense of making these variables. What do I do with them? Reinsert them where necessary in the grammar. So I'll start bottom up. So B will produce, the variables are not going to change, but I'm going to add a use of A every time I see a little a. Not every time, but almost every time. Use of B, or A use of A, or S use of A, or better not change that. All right, let's go up. A will do U, B, A, use of C, S, or use of B, use of C, S, I think. Use of B, A, use of C, or I should change this one because it does have length at least 2. So I should change that one. But S is going to make, oh boy, here's a long one. A, so A, use of A, or double A, or single A, better not change that. A, S, use of A, B, use of B, A, use of A. So can anyone think of a reason why to not use something in C and F? Yeah, too many rules. Exactly. So that's one of the downsides. So S or use of B. So I won't rewrite this for the last step, but you get the idea. And then S0 is all this stuff, or F. Whew, getting pretty a big grammar. But it's starting to get into the right form, right? We now only have start variable to produce epsilon, or variable to single terminal, or variable to only variables. So we're almost there. What's the final step? What's the final step? Yeah, break up the long right-hand sides. Do we have a long right-hand side here? Yeah, we need exactly 2 variables, and is it possible that I have exactly 1 right here? No, because that would be a unit rule, and I already removed those. And we should also check, did any of the previous steps change the language? I should have checked that earlier, but did, say, step 2 change the language? Well, I don't think so, because we're simulating as if we took that variable out by going to epsilon. So that didn't change the language. Did we change the language here? No, because we're simulating as if we took the unit rule. Same reason. Did we change the language in step 4? Well, no, because these brand new variables only make the terminal that was there already, so I definitely didn't change the language. So let's do step 5, which is bring up long right-hand sides. I don't want to erase stuff, but I'll do it. I don't know that or I'll guess all those steps. So step 5. Let's bring up long right-hand sides. So do we have an instance of a long right-hand side? Yeah. So we have 3 variables here, 4 here, and we got to fix those. So what was the way that we did to fix this? Yeah, let's make a brand new variable every single time, and then just have it make 2 of the really long right-hand side. Okay? So what I'm going to really recommend you do here is, since AAA appears twice, make a new variable for both times. Because it makes checking that you didn't change the language easier. Because if you do that, then if you have, say, Y1 makes AA here and here, then when we check that it doesn't change the language, then we don't know that it's a brand new variable every single time. And then we have the case that it may start here and then end up here, because it's the same variable used twice. So I'm going to recommend you use different variables every single time. So let's imagine I rewrote everything up here. So let's say S0 goes to AAA. So S0 goes to AAA. We're going to add rule. What rules should we add? Yeah, so let's say, well, it has to be S0 goes to something. Well, let's make a brand new variable make 2 of these A's, and we can pick whatever one. So let's say X1, so I'm going to number these to make my life easy, not run out of letters. And then X1 is going to make A. So each one of these is going to be a brand new variable, X1, X2, whatever. Okay, so we took care of S0 goes to AAA. This one, should I fix that one?
No.
No, because it's exactly 2 variables, what we want. 2 variables, single terminal. Oh, here's one we want to change. So S0 goes to U. No. Wow, I actually didn't plan that. I really didn't plan that. So AS use of A, and ASU starts the variables and use of A ends it. So another thing. All right. So how am I going to fix this? Well, let's use the same strategy. Let's make a brand new variable that makes AS, and then have that appended on the beginning. So let's make X2 use of A, and X2 make AS. Okay, yeah. Okay, so we handled that guy. This guy, don't touch, don't touch, don't touch. We're going good. Oh, we have 4 now. So if I have 4, how many new variables should I be adding? 2, right? One that'll make these 2, and then one which will make the new variable with the 3rd one. So S0 goes to use of B, A use of CS. That should be replaced with S0 goes to, well, I gotta think ahead. I better have S on the end if I'm doing the front first. Then I should have a variable which will eventually make these 3. So let's say it's X3. And then we gotta have X3 make, say, X4 use of C. So X3 makes X4 use of C. And then obviously X4 makes use of B. So that guy's done. Let's do use of B, use of CS. Use of B, use of CS. So same reasoning. S0 makes x5 s, and x5 makes u sub b, u sub c. Oh boy, another one. So S0 is going to make u sub b a, u sub c. So that converts to S0 makes x6 u sub c, and x6 makes u sub b a, and finally S0 is done. So I'm going to skip all the details and say S will have new variables x7 to I think x12. But so I'm going to ignore all it's the exact same stuff, but I got to have new variables every time. So let's do the last ones. Oh boy. So A is going to u sub b a, u sub c s. I better make two more. So oh boy. So so A goes to x13s. I actually didn't plan on making this so large. So x13 will make x14 u sub c, and x14 will make u sub b a. Technically, you could reuse variables, but it's just for proving correctness much more easily. So let's do the other ones. A goes to u sub b, u sub c s. That'll turn into A goes to x15 s. Yeah, I should have reused variables. U sub c. So we handled that guy. Let's do this one. A goes to u sub b a, u sub c. Yeah, so that's going to turn into A x16 u sub c. x16 is going to make u sub b a. Yeah. Hope I don't make a mistake. And thank goodness. Well, we have another ASU one here, but B. So we only have one more to go. Thank goodness. So A s u sub a. And so that's going to make B goes to x17 u sub a, x17 makes A. I think that's it. If I made a mistake, please tell me. In addition to all the other rules. But I'm just saying add a rule because the rest of the grammar will be unchanged. Thank goodness. But any questions on why we're doing it this way? So again, let's make sure we didn't change the language. So did I change the language? Well, since I added a new variable every time, if I choose to use S0 goes to say x1a, then I have to use x1 to AA because x1's not involved in any other rule since it's a new variable every time. So once I apply this rule, I have to finish it. And that's just simulating, again, one of the original rules of the grammar. So that's exactly what I want. So I didn't change the language by doing this. But now, I should say, this replacement means delete this rule and add those two rules, or three rules. So I'm deleting these guys and adding these ones because I don't want to have these long right-hand sides anymore. But any questions about this? Yeah.
Specifically about this, but would you get one this long on the exam?
No. I actually made this one up yesterday, and I didn't know how long it would be. So this is actually my first time going through it. So yeah, it's a pretty big one, but the fundamental concept is there. It's just simulating what you would have done if you applied a certain rule. But any other questions about this? So let's look at one of the other questions. We do this all the time. So the second one says, so I definitely did not leave enough space for that one. Show that for any non-empty string of length n. If it's in the language of the grammar, then exactly 2n minus 1 rules will be applied. Okay? And I said in, there was a vital component of that I forgot. So what should I say about the grammar first? It's in C and F. That's the important part. So, all right. So let's see. So G in C and F, W in the language of G, the length of W equals N, any derivation of, so I should say N is equal to 1, so it's not empty, of W involves exactly 2n minus 1 rules. So first, ignore the fact that it's not empty. We'll get to that in a second. But, so why would that be true?
Because we can only have 2 variables in that, so it should be like 2n for each one, and then since the final rule would be to a terminal, it's we subtract.
Okay, well, let's see. So one derivation would be, since every single rule that produces a single character, they can only produce a single character, then a derivation might be just start with S and then get to the point where we make a derivation which one variable will produce the first terminal of the string, one will make the second, and then we'll have the last one make the last character. And so how many rule applications would it take me to get from S to this? N minus 1, because for any rule in C and F, when I replace one variable with 2. Since I started with 1, I gotta have n minus 1 to get to n. So this takes n minus 1. But now I want to turn this into a string. Well, how am I going to do that? Well, this variable is going to make the first character. So this is going to be little w1, capital W2, since I can only work with one variable at a time. Well, then I got to do the other ones, right? How many rules would that take to eventually get me to just a terminal string? It would take n because I have n variables, and each one to turn it into its corresponding character takes one rule. So this takes n. In total, 2n minus 1. So this is for non-empty strings. What about the empty string? What is 2n minus 1 for the empty string? 2 times 0 minus 1. Come on. We should be able to do that. Come on. I think it's minus 1, right? Can I have negative number of applications of rules? No. So if the grammar does produce the empty string, where does it have to occur? The start variable, right? So I have to have s goes to epsilon. So how many rule applications does that have? 1. But if I have any non-empty character, it will take 2n minus 1. Sorry, non-empty string should take 2n minus 1. Yeah.
For a grammar that's not a Chomsky Normal Form, there's no way to know how many steps, right?
Yeah. Actually, it could be infinite. And so here's an example. Yeah. So that's definitely not in CNF, but how many ways can I make the empty string? Infinitely many. So you can't say anything about grammars not in CNF. But if they are in CNF, you know exactly what it is. So that's actually another good thing about CNF is that you know exactly how long it'll take to derive a string, which is actually pretty cool. Okay, I don't think I can do the last one, but Any questions about any of this? Yeah, so I start with one variable and I gotta get to n, and each rule application will add one. So the first one will get me to 2, second one will get me to 3, dot, 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 dot. How many will it take me to get to n? N minus 1. Because I start with 1. But any other questions about this? I guess I'll see you tonight, and I guess 2 weeks from now. It's spring break.